Hello everyone! Today we will discuss the differences between the dispose and the close method. Understanding these differences is important for gaining insight into GC. After that, we will explore how GC works. So without further ado, let's dive in. Let me start with a simple example. Imagine you have created a string variable called name with an initial value of Jack inside the method. In the stack, we store the address of the heap, and in the heap, we store the actual data. When the method is completed, the variable will be removed from the stack, and the reference between the heap and the stack will be deleted. The variable in the heap is a candidate for GC now, and the GC will remove that object in the next iteration. Before delving into garbage collector, it's important to understand the differences between the close and the dispose method. When we refer to the close method, we are specifically talking about closing a connection. On the other hand, when we dispose an object, we are essentially nullifying that object. For example, let's consider a DB context. When you run a query, you open a connection, receive the result, and then close the connection. The same process is repeated for subsequent queries. Through all these scenarios, the connection is open and closed, but the DB context objects remain untouched. However, when we dispose the DB context, it is set to null. In other words, the reference to the DB context in the memory stack is removed, and all related connections in the heap are set to null. Let me draw the memory structure again. At top we have stack, and in the bottom we have heap. This is our DB context. So we call the dispose method here, and after calling this dispose method, all the reference between object will set to null. Subsequently, in the next GC iteration, all these objects can be removed because there are no longer any references to them. In our example, let me draw the memory structure again. The stack stores the address of the heap, and in the heap we have actual data where the data is located. When garbage collector starts working at line 6, due to a reference between the stack and heap, it will not remove the object as its root has a reference to the stack. However, once the method completes, the root will be set to null. In the next iteration of GC, it will remove the object and return the allocated space because it's open now and there is no reference between the stack and heap. You might ask, is there a simple way to candidate an object for GC? The answer is yes. For example, we can use a try finally statement. I will finally dispose that object. However, this approach is a bit clumsy. The .NET team introduced using a statement which provides better syntax. In compile time, using will convert to try final block. As you can see here, they are essentially the same, but using offer a better syntax. And in .NET Core, we have a better syntax for using. Now you might ask, when does GC start working? Can it be scheduled? The answer is no. Even if it's scheduled to run every minute, in the first run it might remove about 1 megabyte of data, but in the next run it might remove 1 gigabyte. Therefore, it's not a scheduling thing. Is it triggered by something external? No, nothing indicates GC to start working. So how does it work? Let's visualize the memory structure. At top we have a stack which the GC does not concern. At the bottom we have a heap, and GC is responsible for monitoring the heap. GC utilizes an intelligent algorithm. It calculates the threshold level based on its internal algorithm. When the occupied space in the memory nears this threshold, the GC indicates its task of releasing the space. Sometimes the GC can adjust the threshold level to a different value. After each iteration, GC begins releasing the space again. We previously discussed when GC starts working, but now let's dive into how it actually works. The GC performs three main tasks: marking, compacting, and sweeping the memory. To visualize this process, imagine a memory structure with a stack at top which the GC does not interact with. Instead, it focuses on monitoring the heap. In the first step, the GC identifies and marks certain objects with no references as a candidate for removal. In the next step, it rearranges all the marked and unmarked objects side by side in a process known as compaction. Finally, in the third step, it eliminates all the objects, resulting in a clean and organized heap space. It also worth exploring how the GC divides memory spaces, which is another interesting topic related to this process. The GC divides memory into three generations: generation 0, 1, and 2. In the first iteration, GC removes all marked objects and moves the remaining in use objects to generation 1. Generation 0 has a smaller size than Gen 1. In the next iteration, it removes a marked object in Gen 0, moves the remaining to Gen 1, and removes the some marked object from Gen 1. If there are still objects, GC will move them to Gen 2. Here is a small tip. If some object in Gen 2 stay for a long time with a large size, it might indicate potential memory leak that requires further investigation. Now let's talk about object resurrection. The concept of object resurrection occurs when a class has a finalizer and something goes wrong at that step. At that point, the object must be removed from memory because the GC has marked the object for removal, compacted the memory, and prepared for final sweeping step. However, if an error occurs during the final step, the object needs to be resurrected, meaning it must be retrieved and made active again. That's why it's called resurrection. This topic is quite advanced as there are numerous ways to accomplish it. One approach is to use a try-catch statement, then enclose it in a while loop and repeat it 5 times, for instance. In the catch block, we should invoke the GC re-register for finalize method. There are other potential solutions, but this topic is quite advanced and it is beyond the scope of this video. Thank you so much for watching. If you found this video helpful, please give it a thumbs up and don't forget to subscribe to my channel for more programming tips and tutorials. Until next time, happy coding!